Hello, my dear friends. How are you? In today video, we are going to discussion about one of the most important topic in industrial engineering. So every time I discussion about quality and industrial. In today video, we are specialized discussion about industrial engineering. So let's start about that topic, industrial engineering. So what is industrial engineering? What is industrial engineering? So industrial engineering is the engineering of improving system. An industrial engineer tries to make a system faster, cheaper, safer, better quality, less wasteful, more productivity, more efficient. In simple definition, industrial engineering is the study of how to use people, machine, material, money, information, and the time the best possible way. So simple example, imagine a factory makes 1000 bottles per day. So you notice worker work too far to get materials, worker work too far to get materials, machine wait for materials, some bottles are defective, workers spend time searching for tools, so production is slow. An industrial engineer study the entire process and ask how can you produce, how can you produce the same or better product, so using less time, less money, less effort, and less waste. So this is the industrial engineering, most of it important thing, that one in industrial engineer study the entire process and ask how can you produce the same or better product using less time, less money, less effort, and less waste. This is industrial engineering. So the main objective of the industrial engineering, the main objectives of industrial engineering, the major objectives are, first one is increase productivity. So produce more output using the same resources. Produce more output using the same resources. Productivity equal to output by input. Productivity equal to output divided by input. For example, a worker produces 100 units using 10 hours. A worker produces 100 units using 10 hours. So productivity 100 divided by 10. So 10 units per hour. Reduce cost. Reduce cost. Industrial engineer looks for way to reduce. So industrial engineer look for way to reduce. So material cost, labor cost, material cost, labor cost, machine cost, energy cost, transportation cost, inventory cost, maintenance cost. And third one is improve quality. Improve quality. The goal is not simply to produce more. The goal is not simple to produce more. We must produce good quality products consistently. So then another fourth one is reduce waste. Waste can include extra material, waiting, unnecessary movement, defective product, excess inventory, extra processing, transportation, overproduction. Then another one is improve productivity. Industrial engineer also designs safer. So workspaces, machines, processes, working methods. So another one is improve employee performances. Improve employee performances. A good industrial engineer does not simply make worker work harder. A good industrial engineer does not simply make worker work harder. So instead of they ask, how can you make the job easier and more efficient? So how can you make the job easier and more efficient? What does an industrial engineer do? What does an industrial engineer do? An industrial engineer can work on mainly different activities. So typical responsibility include production planning. So the production planning, process improvement, quality improvement, work measurement, time study, inventory management, supply chain management, facility layout, maintenance planning, cost reduction, operation research, ergonomics, project management, data analysis, lean manufacturing, Six Sigma, scheduling, capacity planning. So important subject in industrial engineering. Important subject in industrial engineering. The major areas are work study. So the major areas are work study, method study, work measurement, time study, motion study, productivity, production planning and control, inventory control, quality control, operation research, facility planning and layout, ergonomics or human factors, maintenance management, supply chain management, lean manufacturing, Six Sigma, project management, cost and value engineering, forecasting, scheduling, reliability, simulation, decision making. So let's understand each one in by one. So let's first one is work study. So what is work study? So work study is one of the most important concept in industrial engineering. It means study how a job is performed and finding the best way to do it. Studying how a job is performed and finding the best way to do it. So work study has two major parts. So work study has two major parts. A method study, so find the best method doing a job. Work measurement, finding the standard time required to perform the job. So work study equal to method study plus work measurement. So that is called work study. Then method study. So what is method study? So method study asks, can you do this job in a better way? Can you do this job in better way? So suppose a worker assembly a product. Suppose can you do this job in a better way? Suppose a worker assembly a product. So current process work to machine. So current process work to machine. Pick up component. So work to machine pick up component. Work back. So pick up tools. Assembly components. Work to inspection area. So industrial engineer may redesign the workplace so that materials are close to the worker, tools are within easy reach, inspection happens at the workstation. Inspection happens at the workstation. This reduces unnecessary movement and saves time. So the main objective, find the easiest and safest. So find the easiest, safest, fastest and most economical method. So work measurement. Then another one is work measurement. What is work measurement? So work measurement determines how much the time should a qualified worker take to complete a job under specified condition. So it is useful for production planning, labor planning, cost estimation, scheduling, incentive system, capacity planning. Then another one is time study. So time study is a technique used to determine the time required for a job. So time study is a technique used to determine the time required for a job. Example, a worker performs a task 5 times. A worker performs a task 5 times. So times 10 seconds, 11 seconds, 9 seconds, 10 seconds, 10 seconds. So average time equal to 10 plus 11 plus 9 plus 10 plus 10 divided by 5. So 10 seconds. The base standard time may also consider worker performance and allows him. A simplified relationship is so normal time equal to observed time into rating factor, and standard time equal to normal time plus allowances. Then another motion study. So motion study examines the movement of worker. Motion study examines the movement of worker. The objective is to eliminate unnecessary movement. For example, imagine a worker repeatedly bend down, turns around, reaches for a tool, walk 5 meters, so comes back. So a better workstation can eliminate many of these movements. Benefits: less worker fatigue, high productivity, lower time, better safety, lower cost. And another one is productivity. So what is productivity? Productivity is a very important industrial engineering concept. Formula: productivity equal to output divided by input. Example: a factory produces 2000 units using 500 labor hours. Productivity: 2000 divided by 500, 4 units per labor hour. So types of productivity: labor productivity, machine productivity, material productivity, capital productivity, total productivity. Then another one is efficiency. Efficiency. What is efficiency? So efficiency tells us how well resources are being used. Efficiency tells us how well resources are being used. A simple formula is efficiency equal to actual output divided by standard output into 100. Actual output divided by standard output into 100%. Example: standard output equal to 100 units. Actual output 9 units. Efficiency: 9 divided by 100 into 100, so 90%. So another one is production planning and control, PPC. Production planning and control. So production planning and control is commonly called as PPC. Production planning and control is commonly called PPC. So its purpose to ensure that the right product is produced. It purpose is to ensure that the right product is to produce. So is the right quantity at the right time within the available resources. So PPC involves planning, routing. So PPC involves planning, routing, scheduling, so dispatching, follow. So routing determines where and how a product should be manufactured. Where and how a product should be manufactured. Example: raw material, cutting, drilling, grinding, assembly, inspection, packing. So this is the sequence of routing. This is the sequence of routing. So where and how a product should be manufactured. Then another one is scheduling. What is scheduling? So scheduling determines when should each operation be performed. So when should each operation be performed. So example: operation and time. So cutting 9 a.m., drilling 10 a.m., grinding till 11 a.m., assembly 1 p.m. So scheduling helps avoid machine idle time, worker idle time, delay or late delivery. Then another one is dispatching. So what is dispatching? So dispatching means giving authorization to start the work. Dispatching means giving authorization to start the work. For example: start job no. So 105 on machine number 4. So it converts the production plan to actual work. Follow. Then another one is follow. Follow-up checks whether production is happening according to plan. So follow-up checks whether the production is happening according to plan. So if there is a delay, we identify the reason and take corrective action. If there is a delay, we identify the reason and take corrective action. Then another one is inventory. What is inventory? So inventory means materials. So inventory materials or products kept for future use. So inventory means material or products kept for future use. Example: raw materials, components, work in progress, finished products, spare parts. So why do we companies keep inventory? Because they need production against. So demand changes, supplier delays, machine breakdown, production interruption. So, but too much inventory is also bad because it requires storage, money, space, insurance, handling. Therefore, industrial engineers try to maintain the right actual amount of inventory. Then types of inventory. So there are different types of inventory are there. First one is raw material. So materials used to make product. So materials used to make products. Examples: steel seed for a car factory. Steel seed for a car factory. And another one is work in progress. Product that are partially completed, finished good. So product ready for customer. Spare parts. So parts kept for maintenance. Then economic order quantity EOQ. So EOQ is used to determine how much should we order each time. How much should we order each time. The basic EOQ formula is EOQ equal to root over 2ds divided by h, where d equal to annual demand, h equal to ordering cost per order, h equal to holding cost per unit per year. The idea is to balance. So ordering cost is your holding cost. So if you order frequently, if you order too frequently, ordering cost increases. If you order too much, storage or holding cost increases. So EOQ tries to find a good balance. Then reorder point. So reorder point tells us. Reorder point tells us when should you place a new order. When should you place a new order? A simple formula ROP, demand during lead time plus safety stock. For example, if a company uses 100 units per day and supplier take 5 days, so demand using lead time, so 100 into 5, so 500 units. If safety stocks is 100 units, so ROP 500 plus on 600 units. When inventory reaches about 600 units, a new order should be placed. And quality control, then QC, quality control. So quality means product or service. So quality means product or service meet the required specification and customer expectation. So quality control focus on identifying and controlling problems. Example: checking dimension, testing strength, checking defects, inspection materials. So monitoring processes. Monitoring process. So quality assurance versus quality control. Quality assurance versus quality control. Quality assurance versus quality control. So quality assurance. So quality assurance focus on preventing problems. So quality assurance focus on preventing problems. So quality control focus on detecting and controlling problems. Quality assurance focus on preventing problems. Quality control focus on detecting or controlling problems. So simply to remember: quality assurance prevent, quality control detect, control. Then statistical quality control. What is statistical quality control? Statistics can be used to monitor manufacturing process. So important tools include control chart, histogram, Pareto charts, scatter diagram, check sheet, cause and effect diagram, process capability analysis. These are often associated with the 7 basic quality tools. And another one is control chart. What is control chart? So a control chart helps determine whether a process is behaving normally. A control chart helps determine whether a process is having normally. It generally has central line CL, upper control line UCL, lower control line LCL. So if measurement BFC unusually, the process may have a special cause that needs to investigation. And another one is Pareto analysis. So Pareto analysis is based on the idea that a relatively small number of causes can create a large percentage of problems. Example: a factory has 1,000 defects. So analysis shows scratches 400, wrong dimension 250, missing component 200, other 150. So instead of trying to solve this anything at once, we first focus on the biggest causes. This is called as the Pareto thinking. Then another one is fishbone diagram. So what is fishbone diagram? So a fishbone diagram is also called a cause effect diagram or a Ishikawa diagram. So it helps to identify possible causes of a problem. So common category include man, machine, method, material, measurement, environment. For example, so problem high product defects. Problem causes material, machine poor maintenance, material poor quality raw materials, method incorrect procedure, man insufficient training, measurement inaccurate instrument. So operation research. So operation research is the use of mathematical models and analytical methods to make better decisions. So it helps answer questions such as so which product should you manufacture, which product should you manufacture, how much units should you produce, which route is best, how should your worker be assigned, how should your machine be scheduled, how can transportation cost be minimized. Then line program. So line program LP is a major operation research technique. A line programming. So a linear programming LP is a major operations using technique. So it is used when you want to maximize or minimize something while satisfying restriction. While satisfying restriction. So example, a factory makes product A, product B. So both requires labor, material, machine time. The company wants to maximize profits while staying within the help of resources. So linear program can determine the best production quantities. Then transportation problem. So transportation models helps determine. So transportation model helps determine. So how should your products be transported from resource to destination at minimum cost. So example, so the factory supply four warehouses. So we want to decide how many units should go from factory one to warehouse one. So how many from factory one to warehouse two. So etc. The goal is often minimize the total transportation cost. An assignment problem. Then assignment problem. So assignment problem determines which person should be assigned to which job. So example, four workers and four jobs. So each worker has a different time for each job. So we want to assign workers so that total time is minimized. Then queuing theory. What is queuing theory? So queuing theory studies waiting lines. Example, customer waiting a plan, car waiting a toll booth, patient waiting a hospital, job waiting for a machine, packet waiting in a computer network. The objective is to balance. So service capacity equal to waiting time equal to cost. So too few service point, long waiting time, too many service point, unnecessary cost. And facility layout. What is facility layout? A facility layout means so arrange machine, department, worker, strong area, and other facility in the best possible way. Say good layout reduces material movement, transportation, waiting, space requirements, production time. And types of layout. So types of layout. So important types are product layout. Important types are product layout. Machine are arranged according to the sequence of production. Example: machine A, machine B, machine C, machine D. So used for high volume production. And process layout. So similar machines are grouped together. So similar machines are grouped together. Example: all drilling machine grouped together, all drilling machine together, all grinding machine together, all milling machine together. So used for varied products. And fixed position layout. So there is a fixed position layout. So the product set and the product stays in one location while worker, machine and materials move to it. So fixed layout. So the product stay in one location while worker, machine and materials move to it. Example, shipbuilding, large construction project, aircraft assembly. And cellular layout. What is cellular layout? Machines are grouped into cell to manufacture family of similar products. And ergonomics. What is ergonomics? So ergonomics means designing worker to fit the human beings. In simple word, make the workplace suitable for the worker rather than focusing on the worker who adapt to a poor workplace. So it consider human body dimension, posture, fatigue, workstation height, lighting, noise, temperature, tool design, repetitive movement. Example, if a worker must continuously bend down to pick metal, we can raise the metal container to a comfortable height. Benefit less fatigue, fewer injury, better productivity, better comfort. And another one is human factor. So human factor study how interact with. So human factor study how human interact with machine, tool, process, technology, work environment. So it is closely related to ergonomics and lean manufacturing. Lean manufacturing focus on creating one more value. Creating more value for the customer while eliminating waste. The famous waste in the lean commonly recognized T modes: transportation, inventory, motion, waiting, overproduction, overprocessing, defects, skill or talent not utilized. Some lean frameworks use slightly different classification, but the basic idea is the same. Remove activities that do not create value. So just in time JIT. So JIT means get the right material, get the right quantity. So get the right material in the right quantity at the right time. So instead of keeping huge amount of inventory, materials arrive close to when they are needed. So advantages: lower inventory, less storage, less waste, faster production. But the JIT requires a reliable supply and stable process. And another one is Kaizen. So Kaizen means continuous improvement. The idea is you don't wait for one huge improvement, make many small improvement continuously. So example in today worker takes 60 seconds, after improvement 55 seconds, another improvement 52 seconds, another 50 seconds. Small improvement can create major long-term benefit. And another one is 5Ps. So 5Ps is a workspace organization method. These five Japanese terms are commonly translated as sort, remove unnecessary items, set in order, arrange necessary item properly, sign, clean the workspace, standardize, create the standard procedure, sustain, maintain the system. Example, if every tool has a fixed location, workers don't waste time searching for the tool. And Six Sigma. So Six Sigma is a data-driven approach. Six Sigma is a data-driven approach for reducing process variation and defects. The famous improvement methodology is DMAP. So define the problems, measure, to collect the data, analyze, find the causes, improve, implement solution, control, maintain the improvement. Then another is PDCA cycle. So another important continuous improvement method is PDC. P means plan. So identify the problems and plan an improvement. D means try the solution. C means check, study the results. A means act, standardize the successful improvement or modify approve. Then maintenance. So maintenance means keeping equipment in good working condition. Maintenance means keeping equipment in good working condition. Types include breakdown maintenance, so repair the machine after it faults. Preventive maintenance, so perform maintenance before future based on the plant schedule. Predictive maintenance, so use data or condition monitoring to predict when maintenance may be needed. So example of monitoring: vibration, temperature, noise, oil condition. Then total productive maintenance (TPM). TPM aims to improve equipment. TPM aims to improve equipment effectiveness. By involving the whole organization. TPM aims to improve equipment effectiveness by improving whole organization. It focuses on preventing breakdown, reduce defect, reduce downtime, improve equipment utilization, improving operation and basic equipment care. So overall equipment effectiveness OE. OE is widely used in evaluating equipment effectiveness. The basic relationship is OE equal to availability into performance into quality. For example, availability 90%, performance 90%, quality 90-80. Then OE equal to 0.90, 0.95 into 0.98. So all and overall 0.8370, so 83.79%. Then another one is supply chain management. So what is supply chain management? So a supply chain is a network involved in producing and delivering a product. A supply chain, so a simple supply chain, supplier, factory, warehouse, distributor, retailer, customer. So supply chain management coordinates purchasing, production, inventory, transportation, warehousing, distribution, information. The goal is to deliver the right product. The goal is to deliver the right product. The goal is to deliver the right product at the right time. The goal is to deliver the right product at the right time, right place, and the right quantity and the right cost. That is called the supply chain management. Then another one is the logistics. So logistics maintain. So logistics mainly deals with the movement and storage of goods. So it includes transportation, warehousing, material handling, distribution, order fulfillment. And another one is forecasting. So forecasting means predicting future demand or condition using available information. Example, a company sold January 1000 units, February 1100, March 1200, April 1300. The company can use forecasting method to estimate future demand. Forecasting helps with production planning, inventory, workforce planning, purchasing, capacity planning. Then capacity planning. So capacity means capacity planning. Capacity means the maximum amount of a work. So the maximum amount of work a system can produce under specified condition. Example, a machine can produce 500 units a day. If customer demand is 800 units a day, the company can capacity problems. So possible solution, add another machine, increase working hours, improve efficiency, reduce setup time, outsource some production. And another one is bottleneck. So what is bottleneck? A bottleneck is a process that limits the overall flow. Example, machine A 100 units per hour, machine B 40 units, machine C 100 units, machine B is machine B is the bottleneck. So even though A and C can produce 100 units per hour, the overall flow is restricted by B. Therefore, improve the bottleneck and significantly improve the whole system. Then theory of constraint. Then theory of constraint. The theory of constraint focuses on identifying and managing the system biggest constraint. A simple approach so identify the constraint, get maximum useful output from it, align other activity with it, increase its capacity if necessary, repeat when another constraint appears. Prepare value engineering. Value engineering. So value engineering tries to achieve the required function at the lowest trial cost without unnecessary reducing quality or performance. A simple idea value equal to function divided by cost. Example, if two components perform the same required function but one cost much more. So engineer investigate whether the cheaper alternatives can safely the requirement. And another one is cost engineering. So what is cost engineering? So cost engineering involves cost estimation, cost control, budgeting, economic analysis, cost reduction. So industrial engineering is to understand where money is being spent or where is improvement are possible. So project management. So industrial engineer may manage projects such as factory expansion, new production line, automation projects, process improvement, new product introduction. So important project management concepts include scope, time, cost, quality, risks, and resources. CPM. What is CPM? So critical path method. So CPM critical path method is used to project scheduling. So it identifies the sequence of activities that determines the minimum project completion time. Activities activities on the critical path. So activities on the critical path are essentially zero for total float in the standard CPM model. If critical activities delay, the overall projection can be delayed. Useless corrective action is taken. Then part. So program evaluate and review technique. It is useful when activity times are uncertain. So POT commonly uses three estimates. So optimization time A, most likely time M, and pessimistic time B. So expect time T equal to A plus 4M plus B divided by 6. And simulation. What is simulation? So simulation means creating a model. So simulation means creating a model of a real system and experimenting with it. Example: a factory wants to know whether adding one more machine will reduce waiting time. So instead of immediately buying a machine, the company can create a simulation model and test different scenarios. So simulation is useful for quiz, manufacturing system, logistics, hospitals, transportation, service system. Reliability. Reliability. So what is reliability means? The probability that a system performs its required function for a specified time under specified condition. Example: if a machine has a high reliability, it can operate for a long time without a failure. Important concept: failure rate, mean time between failure, mean time to repair, availability. A common used relationship is availability approximately MTPF divided by MTPF plus MTTR when the relevant assumption apply. Then another one is automation. So what is automation? So industrial engineering is closely connected with the automation. Example: robots, CNC machine, automated inspection, automated storage, conveyor system, sensor, manufacturing execution system. So the industrial engineer asks, should this process be automated, and will automation actually improve overall system? So automation is not automatically beneficial. It is if it creates unnecessary cost or complexity. So and then another one is industrial 4.0. What is industry 4.0? So modern industrial engineering also includes Industry 4.0. It involves technologies such as Internet of Things, artificial intelligence, machine learning, robotics, cloud computing, big data, digital twins, sensor, cyber physical system, advanced analytics. Example: a machine has sensor that continuously collect vibration and temperature data. So AI or data analysis can identify unusual pattern and helps predict maintenance needs. And digital twins. What is digital twins? So a digital twins is a digital representation or a model of a physical system that can connect it to a real world data. For example, a factory can have a digital model of its production line. So engineer can use it to study. So production flow, machine utilization, bottlenecks, capacity, possible improvement. So material handling. So material handling means improving and storing and controlling materials. Example: conveyors, forklifts, cranes, automation guided vehicles, storage system. A good material handling system should reduce a good material handling system should reduce distance, handling, damage, waiting, cost. Then line balancing. So what is line balancing? So line balancing is important in assembly line. Suppose core operation requires A 2 minutes, B 3 minutes, C 5 minutes, D 2 minutes. If one workstation has much more work than other, so workers or other station may be wait. Line balancing tries to distribute work more evenly. The goal is to reduce idle time, bottlenecks, production imbalance. And another one is takt time. What is takt time? So takt time tells us how frequently a product must be completed to meet customer demand. Formula takt time equal to available total time divided by customer demand. Example: available production time 420 minutes per day. Demand 200 units per day. Takt time 420 divided 2 minutes per unit. So the production system needs to complete approximately 1 unit every 2 minutes to meet the demand. And another one is cycle time. So what is cycle time? So cycle time is the actual time required to complete a unit or process cycle. Depend on the definition being used. So important difference. So takt time customer demand requirement. Cycle time process performance. If takt time 2 minutes, cycle time 3 minutes, the process cannot meet the current rate. So lead time. So what is lead time? So lead time is the total time from a beginning of a process or order to the required completion or delivery point. So start to end, that is called lead time. Example: customer order today, production arrive after 7 days. So lead time 7 days. So then another one is through output time. Through output is the rate at which a system produces completed output. Through output is the rate at the system produces completed output. Example: a factory produces 500 units in 10 hours. Through output 500 divided by 10, so 50 units per hour. Then value stream mapping, VSM, value stream mapping. So value stream mapping is a lean tool used to visualize the flow of materials, information processing from supplier to customer. It helps identify waiting, excess inventory, unnecessary process, transportation bottlenecks. Then standardization. Standardization means establishing the best currently known method and making it consistent. Example: instead of every worker assembling a product differently, the company created standard procedure. Benefits: so consistent quality, easier training, less variation, easier improvement, better safety. Then another one is industrial safety. So industrial engineer also consider workspace safety. Important area: hazard identification, risk assessment, machine guarding, personal protective equipment, safe work procedure, emergency planning, ergonomics hazards, fire safety. The basic idea is prevent accident. So prevent accident rather than simple reacting after accident happens. And another industrial engineering example. So complete factory. So let's start about industrial engineering, completely factory. So imagine a company manufacture bicycle. Step 1 purchasing by steel, wheel, tire, brakes, seats. Step 2 production steel, cutting, welding, painting, assembly. Step 3 quality inspect frame dimension, paint, brakes, wheels, etc. Then inventory store raw material, components, finished bicycle. Then step 8 transportation move finished bicycle to warehouse and customer. And now the industrial engineers study the entire system. They ask, can you reduce material movement? Can you reduce waiting? Can you reduce repairs? Can you reduce inventory? Can you improve work safety? Can you increase machine utilization? Can you reduce production cost? Can you deliver faster? This is the heart of an industrial engineering. Then important industrial engineering formula. Here are some useful formula for to remember. Productivity equal to output by input. Labor productivity, so output divided by labor hour. Efficiency, actual output divided by standard output into 100%. 100. So utilization, actual operating time divided by available time into 100. EOQ, so root over 2ds divided by h. Reorder point, so ROP, so demand during lead time plus safety stock, takt time, available production time divided by customer demand, OE availability into performance into quality, availability MTBF divided by MTBF plus MTTR, pot expert time T equal to A plus 4M plus B divided by 6. So an industrial engineering versus mechanical engineering. They are related, but their focus is different. Mechanical engineering, so mainly focus on machine, mechanical system, design, thermodynamics, machine, mechanics, manufacturing process. Industrial engineering mainly focus on process, productivity, people, quality, cost, production system, optimization system, supply chain, operation. So a mechanical engineer may design a machine. An industrial engineer may determine how should that machine be integrated into the factory and to maximize productivity while controlling the cost, quite quality, safety and flow. And skill need for an industrial engineering. A good industrial engineer should deploy technical skill, mathematics, statistics, operation research, production system, quality management, engineering economics, data analysis, optimization, simulation. Software skill depend on the job, Excel, SQL, Python, MATLAB, Power BI, CAD tool, simulation software, ERP, MRP system. Soft skill, so soft skills communication problem solving, teamwork, leadership, critical thinking, presentation, decision making. Wherein the industrial engineer works, industrial engineer can work in many industries, so manufacture, automobile, electronics, aerospace, machinery, consumer products, service, hospital, banks, hotel, retail, self-container, logistics, warehouse, transportation, e-commerce, technology, data operation, process improvement, business operation, government or publisher, transportation, public services, information, infrastructure operation. A simple way to remember industrial engineering. Think about a factory with five basic things: people, machine, material, money, information. So industrial engineer try to organize these things so that input process output becomes so factory plus cheaper, faster plus cheaper plus safer plus better quality plus less waste. The big picture. So you can understand the entire subject through this chain. Customer demand, forecasting, production planning, purchasing or supply chain, inventory, production, work study plus method study, scheduling, quality control, maintenance, material handling, finished good, warehouse, distribution, customer. And industrial engineering connects and improve all these activities. The most important topic to study first. So if you are learning industrial engineering for college or exam, recommended starting in this level and fundamentals. So industrial engineering introduction, productivity, work study, method study, time study, motion study. First one, introduction, production planning and control, routing, scheduling, dispatching, line balancing, capacity planning. Inventory. So inventory concept, EOQ, reorder point, safety stock, ABC analysis. And quality. Quality concept, statical quality control, control chart, preparatory chart, fishbone diagram, process capability. Operation research, linear programming, transportation, assignment, weighing, simulation, decision analysis. So modern AI, lean manufacturing, 5S, Kaizen, JIT, Six Sigma, TPM, OE, supply chain, industry 4.0. So one line definition for example. Here is the quick definition can organize. Industrial engineering optimization, integrated system, improving people, machine, information and equipment and energy, productivity, ratio of output to input, work study, systematic examination of work to improve efficiency, method study, finding the best method of performing a job, time study, determining the time required to perform a task, motion study, study of worker movement to eliminate unnecessary motion, PPC, planning and controlling production activities, inventories, stock of materials or product kept for future use, quality, degree to which a product or service meet requirement and expectation, plain systematic approach to creating value while eliminating waste, Kaizen continuous improvement, 5S workplace organization and discipline method, Six Sigma data driven approach to reduce variation and defects, ergonomics design work system to fit human capabilities and limitation, supply chain network involved in sourcing, production and delivering goods or services, bottleneck. So constant that limits the output of overall systems. We measure combining availability performance and quality. Takt required production rate based on the customer demand. Operation research, analytics and mathematical method for better decision making. Final simple definition. So if you remember one thing, remember this industrial engineering is about finding a better way to do work. An industrial engineer looks at a completely system and asks, how can you make it more productive? How can you reduce it? How can you reduce waste? How can you improve quality? How can you make it safer? How can you reduce time? How can you use people, machine and material more effectively? This is what industrial engineering is about. So this is my part 1 video. So let's discussion about my part 2 video. So this video you can understand in industrial engineering so many things. So this is my part 2 video. So this industrial engineering subjects. So how to do in details. So he will explain that with Mr. Sagar Kosik. So first is topic subjected information, importance and application. So you can read about all these things. I will explain or see in that picture. Then you can clearly understand in everything. So overview of industrial engineering. So see that is how you can overview of the industrial engineering. Then location, selection and plant layout. So location, selection and plant layout. The production planning and control. Production planning and control. So productivity and work study. Productivity and work study. So then in the job evaluation and wage plan. Job evaluation and wage plan. How to do? You can see that is the image. Then industrial legislation. Industrial legislation. Then inspection and statical QC. Inspection and statical QC. Then entrepreneurship. Entrepreneurship. Then this is the part 2 video. We will explain. Topics: factor affecting plant layout, factor affecting plant layout, urban and rural area, difference urban and rural area. So this is the dynamic nature of plant layout, and this is the effective plant layout, and this is the factor that affecting plant layout, and this is the factor that affecting plant layout, and this is the urban areas, and this is the rural areas. Difference between urban and rural areas. So this is the in video 3. This is the topic: product layout, process layout, fixed layout. So types of plant layout: product layout, process layout, fixed layout. This is the fixed layout. This is the product layout or process layout. And this is the another topics, that is the job or batch production or mass production. Types of production system. This is the types of production system. You can read about that. And this is the job production. This is the job production. And this is the batch production. This is the batch production. This is the mass production. This is the mass production. This is the continuous production. All difference between job, batch, and the flow production system. This is an overview of PPC. This is the phases of PPC. And this is the procedure of PPC. The procedure of PPC. Objective of PPC. Procedure of PPC. And this is another topics, and we will cover cell forecasting, objective of cell forecasting, types of cell forecasting, sales forecasting, importance of sales forecasting, objective of sales forecasting, types of sales forecasting, steps for process planning. So topics: least square method, numerical, least square method, numerical, least square method, numericals. This is the value. This one also value how to calculate that numerical method. And this is the another topics: moving average method, numericals. This is the moving methods. This is the numericals. And this one also one numericals. This one also same thing. He will explain it clearly. And let's discuss about another topic, that is the exponential smoothing method or numericals. This is the exponential smoothing method, and this is the numerical. And another topic is loading, scheduling, and line of balancing. So this is the loading, this is the loading, and this is the scheduling, this is the scheduling, and this is the line balancing, this is the line balancing, and procedure of line balancing. This is the procedure of the line balancing. And let's discuss about another topic: productivity, increase in power, decrease in productivity. This is the productivity and the types of productivity, and reason for decrease in productivity. Reason for decrease in productivity. So factors that are affecting productivity, factors that are affecting productivity. So advantages of productivity. And another topic productivity improvement tools. Productivity improvement tools. How to improve productivity. So productivity improvement tools. How to improve productivity. So management approach tools and techniques. So resource based tools and technique. So equipment related tools and techniques, employee related tools and techniques, technology based tools and technologies. So this is the productivity improvement techniques. So you can read about all these things. This is the another topics method study, objectives of method study, and procedure of method study. This is the work study. This is the work study. You can read about that. This is called work study. This is the work study, and this is the work study. This is the work study procedures. So you can read about that. And this is the method study. What is method study? Then objectives of method study. The objectives of method study and procedure of method study. The procedure of method study. An example of method study. Then another topic is different process symbol, operational process set, flow process set. This is the recording techniques, and this is the operational process set, and this is the flow process set, and this is the another topic two-handed process set, multiple activity set, travel set, and this is the two-handed process set, two-handed process set, left and right, and this is the multiple activity set. This is the multiple activity chat, travel chat, and this is the another topic steering diagram, work measurement, time study. This is the steering diagram, and this is the steering diagram, and this is the work measurement, and this is the work measurement techniques. Then objectives of work measurement, time study techniques. Then it is the another topic time study, PMTS, ergonomics. So work measurement technique, stopwatch, work sampling. So predetermined motion and time system, predetermined motions and time systems. So objectives of predetermined motions and time systems, and predetermined motion and time systems. And another one is work measurement technique, ergonomics. Ergonomics. What is ergonomics? See, you can read about all these things. Another topic is job evaluation, objectives of job evaluation, procedure of job evaluation. Job evaluation, objectives of job evaluation, procedure of job evaluation, methods of job evaluation, steps of ranking method, steps for ranking method. Then another one is merit rating, objectives of merit rating, difference between job evaluation and merit rating. So that one merit rating, objectives of merit ratings. So benefits of merit rating. So difference between job evaluation and merit rating. Then topics wages and types of wages. So factory determine wage structure and wage initiative plans. This is the wages. A factor defined determining wage structure, and this is the types of wages, and this is the wage incentives, and this is the wage incentive plans, and another topic incentives, teller differential versus piece rate system, direct differential piece rate system, incentives, wage incentive plans. So teller differential piece rate system. So Merrick differential piece rate system. Then industrial engineering, Harsley incentive plan, Ravens plans, Epson efficiency plan. So Harsley incentive plans, Ravens plans, Ravens efficiency plans. Is the another topic industrial legislation, needs of industrial legislation act. This is the industrial legislation act, Factory Act 1948, so Industrial Dispute Act 1947, Industrial so topics Workmen Compensation Act 1992, 1996, 1952. This is the Workmen Compensation Act, Trade Union Act, Employee Provident Fund Scheme, Payment of Bonus, Payment of Bonus Act, Payment of Bonus Act, topics inspection, function of inspection, types of inspection, which is the inspection, which the types of inspection, and then this is also types of inspection, function of inspection, objective of inspection, industrial engineer topics quality control, benefits of quality control, quality is the quality, and this is also the quality, determinants of quality, factor affecting quality, quality control, benefits of quality control, and another industrial engineering total quality management steps for TQM quality circle. This is the total quality management, TQM steps, quality circles, advantages of quality circles, and another one is the topics SQC variable attributes, statistical quality control, objective of statistical quality control, variables, is the attributes, is the types of control chart, and another industrial engineering normal distribution curve, Six Sigma concept, normal distribution curves, and normal distribution curves, and properties of normal distribution curve. So Six Sigma concept limits, and another is operating characteristics of manufacturer rights or consumer risks. So operating characteristics curve, operating characteristics curve, a basic definition, acceptance of sampling, and another topic is X and R chart numerical. This is the type of control charts. This is the X and R chart. So this is also X and R chart. So X and R chart numerical. This one also chart. And another industrial engineer P charts, numericals. Types of control charts. P charts. Example of the P charts. This one also one more example of the P charts. This one also P charts. This one also same like that. Charts and industrial engineering tools and pick charts numericals. So types of control charts and pick charts. This is sample number, non-number of defects. So you can read about all these things. So this is also improvement. This is an improvement in NP charts. Another topic is entrepreneurship or source of industrial finance. Government intensive and entrepreneurship as an industrial engineering. Characteristics of industrial entrepreneur. Characteristics of entrepreneur. Source of Indian finance. Source of Indian finance. So government incentives to entrepreneurs. Government incentives to entrepreneur. And another topic is definition of waste, classification of scrap. So this is the waste. There are so many wastes are there. So we can read about all these things in clearly in classification of waste. So classification of waste, region per generation and accumulation of absolute surplus and scrap tons, region per generation and absolute factor involved in waste formation, faculty transportation method. So another one is the improper storage, backup control procedure, backup wastage control. So clinical research, management research. So this is all about my part 2 video. So let's discussion about part 3. This video also more important introduction to industrial engineering. So I can read all about that industrial engineering, industrial production, quality something. One is a piece of the application, so fixed of application of industrial engineering, role and circle of industrial engineering, role of industrial engineering. So that is the field of the application of industrial engineering. So you can build your own language and you can clearly understand in everything. Then another one is these are all the same thing. Some question really invite that. That is another one is productivity. Productivity output divided input productivity. Markup of value of goods, value of plant resource. So types of productivity is the types of productivity. Total productivity, difference between production and productivity procedure, industrial engineering. So this is the product and productivity procedure. So this can be activated through the following pages. You can read about all these things. So I'll share with you. You can details. You can write it. That is also most important topic. So you can see all these things. See this one also all these things you can read and write it. You know all these things you can read it. This one the another topic industrial engineering job or hybrid production mass of continuous production and batch or quantity production. So this one you will explain in everything also advantages. So, this is the mass of continuous production. And this one is the batch of the final production. This one also most important thing in industrial engineering. You can read about all these things. And this one also most important thing. You can read about all these things like techniques of work study, method study, work measurement. And this one also method study. This one also method study. And this one also workflow of the industrial engineering. So one time this one already writing in a PDF. One time I will explain in everything. So you can clearly understand in all these things. So I am not explaining, you can do it. I believe that we can do it 100% in everything. That one also most important thing. This one also most important things in industrial engineering. You can read and write these all these things. Then you can clearly understand what is industrial engineering, what is the mechanical engineering. So you can read about all these things. So application of work study. So here that one also I'm share with you. So this one also method study. This one also method study. Then the select, record, examine, examine, select, measure, define, measure. So you can define, install, maintain, define, install, maintain, and you will explain in everything. So you can read about this all these things. So this is the process, how to this process, operation, inspection, transportation. You will read in graph symbol operation, this is also operation, this one also operation, and this one is your inspection, and this one is the transportation, this one is the delay, and this one is the storage, this one is the operation from inspection, operation from transportation, okay, inspection for storage. So industrial engineering or you that one also you can read about all these things, some questions and an answer. You can do it in your own way. Then you can clearly understand in everything. So as it is possible, you can start with your own day, otherwise leave it. So see which type of questions here comes and so you read it. And industrial engineering and core. So that one also most important thing. But you will try and industrial engineering for and oversee. So one example you can also write it. So once you can see it. And industrial engineering, OC and LC. That are also most important thing. So you can read about all these things. So industrial engineering and OC. That one also most important thing. One by one discussion about. So this is my part 3 video and that video also more useful other industrial engineering. Let's discussion about another video. So industrial engineering. So that is the image you can read about all these things. Then you can understand how the industrial before time and now time, how the industry day by day will changes. So let's discussion about that. So this is the industrial engineering revolution. So you can read about all these things. So see that is the image. You can understand in day by day how industry will develop and how see that you can read about all these things. So this is all our scientist history of the development. So this is the introduction to the industrial engineering. So this is the contribution to industrial engineering. This is the contribution to industrial engineering. You can read about all these things. This is the contribution to the industrial engineering and to to all these things. And this is the contribution to the industrial engineering, and receive manual contribution to the industrial engineering. The activities of the industrial engineering. What are the activities are done in the industrial engineering? And industrial approach. So industrial approach. You can read about all these things. And this is the objective of the industrial engineering. And it is the function of an industrial engineer. And it is the technique of an industrial engineer. So you can read about all these things. This is the techniques of industrial engineering. And it is the technique of industrial engineer. And receive and also technique of the industrial engineer. Industrial engineering in organization. So industrial engineering in organization. Industrial engineering in organization. So industrial engineering service sector. Systems approach. Systems approach. Systems approach. Productivity. 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 So this is called productivity. This is productivity. Definitions of productivity. And this is the production and productivity. This is the production and productivity. And this is the production and productivity. This is the production and productivity. The expectation and benefits from productivity. Expectation and benefits from productivity. This is the dynamics of productivity change. And this is the productivity measures. This is the productivity measures. And it is the productivity calculation. How to calculate this productivity? You can calculate all these things: labor, capital, material, and everything. With the productivity measurement models, and with the factor influence productivity. Factor influence productivity. And also factor influence productivity. This one also factor influence productivity. Then is the factor influence productivity. This one is the work study. This one is the work study. And this one also work study. And this one is also work study procedure. Work study procedure. Work study procedure. And is the work simplification and work study. Work simplification and work study. The human consideration in work study and the management, work study and supervisor, work study and the workers, work study man, influence of method and time study, influence of method and time study. So concept of work content, concept of work content, reason for excess work content, reason for excess work content, techniques to reduce work content. This is the concept and factor governing plant location. This is the method study procedure. This is the method study procedure. This is the method study. Method study symbols. Allowances in work manager measurement. Development selection of new method. Principle of motion economy. Performance rating. Performance rating. Performance rating. This one also performance rating. Performance rating. So constituent of standard time. Activity of industrial engineering. Techniques of industrial engineering. Techniques of industrial engineering. Techniques of industrial engineering. And this is the top skill of industrial engineering. Top skills of industrial engineering. Top skill of industrial engineering. This is the top skill of industrial engineering. So this is the top skill of industrial engineering. So you can read about all these things, then you can clearly understand about that. And this is the production ergonomics. That is the human ergonomics and production ergonomics. What is ergonomics and how the industrial engineer works? So let's discuss about that ergonomics, production to ergonomics. So you can read about all these things, then you can clearly understand about what is ergonomics and why the benefits and why to identify, and you can read about all these things, then you can clearly understand about that. So this is the elements of the ergonomics. You can read about all these things. Meaning of the term links. So we can read about all these things. Then you can clearly understand about that. Material process flow. This is all about for the industrial engineering. So thank you for watching this video. Thank you so much.